Hey math fans, we're on section 6.2.1. Let's get started. In this section, we're going to be calculating perimeter, and we will also be calculating area. Perimeter is the distance around a polygon, whereas the area is the amount of space inside the polygon. Here are some key concepts. So the perimeter is the sum of the lengths of the sides of a polygon. So we're going to be using the distance formula if we have the coordinates. We'll find the distance of all the sides and we'll add them together, which will involve most likely adding radicals. The area, though, will be using one of the many area formulas. For example, a triangle is 1/2 base times height. You probably already knew that. And the area of a rectangle is just the base times the height. When you're calculating the area of a rectangle, you can take a couple shortcuts, like we know for a fact that a rectangle's opposite sides are going to be congruent. So we could only need to figure out what's the distance of one of the sides, multiply it by 2, and then the other side, multiply it by 2. Here are some common misconceptions and errors. Example 1, triangle ABC has vertices A, -3, 1, B, 1, 3, and C, 2, -4. Calculate the perimeter of the triangle. So like I mentioned before, we're going to be using the distance formula. So as you can see, I've shown all my work. I've plugged in the values for points A and B. So I have -3, 1, and then 1, 3 for B. Substituted into the distance formula, and I get a final length of radical 20. I calculate the length of BC also using the distance formula and the length of CA. So my final move is to calculate the entire perimeter, which would be the length of AB plus BC plus CA, which is radical 20 plus radical 50 plus radical 50, which is 18.6 approximately if we were to use our calculator. Now, that is not an exact answer. When you get to upper level math, they're going to want you to keep them as radicals. And notice radical 20 and radical 50 are not simplified either. So first things first, we can add both the radical 50s together and get radical 50 plus radical 50 is 2 radical 50. And then we can simplify. There's a perfect square of 4 inside the radical 20. There's a perfect square of 25 inside of the radical 50. And that simplifies to 2 radical 5 plus 5 radical 2. Now notice the radicals are not the same. Radical 5 and radical 2 cannot be combined together. You leave the answer just as it is. Example 3, triangle ABC has vertices A, 1, -1, B, 4, 3, and C, 5, -3. Calculate the area of the triangle. Now the book outlines a different method than what I'm going to show you. I'm going to show you the creating a rectangle method, which means that once you have graphed your triangle, what we could do is we could create a rectangle around the triangle, in which case the triangle vertices are touching each of the sides of the rectangle. You're not supposed to go any larger or any smaller. Notice how point A, point B, and point C all lie on the rectangle. Now the theory is this. I could figure out the area of that rectangle, but I don't want the area of the rectangle. I want the area of the triangle. So what I could do is figure out the area of this triangle, because that is a right triangle. And if I was to subtract that off, find the area of this triangle, subtract that off, find the area of this triangle, subtract that off, wouldn't I have the area of the triangle that I'm looking for left over? So let's do it that way. That's called using the area addition postulate, which means the sum of all the areas will add up to whatever it is you're looking for. Or in this case, we're going to be subtracting off areas here. So the area of the rectangle is 6 units by 4 units, so it's going to be 6 times 4 equals 24. The first right triangle is 1/2 3 units by 4 units. And so that's an area of 6 square units. Second triangle is going to be 3 square units. And the third triangle is 4 square units. So if I want that leftover space inside of that rectangle with all of those areas of those triangles gone, I'm going to have a final computation of 24, which is the rectangle, minus 6, minus 3, minus 4, which are the 3 triangles. And I have an area of 11 left over for the final answer for triangle ABC has an area of 11 square units. Now, the book does it a different method, and by all means, if you want to use algebra and find the height of the triangle and solve it that way, that's fine also to use, but I'm going to say that this is a lot easier. Rectangle ABCD has vertices of A, -3, 4, B, -1, 2, C, 2, 1, and D, 0, -5. Calculate the area of the rectangle. Now, you could use the same method again, but that would be kind of pointless because we already have a rectangle. So I would suggest, why don't we just use the distance formula? And remember, a rectangle is base times height. So we just need to find the distance of the base, find the distance of the height, multiply those together because it's already given to us that this is a rectangle. The problem with the triangle is we didn't know necessarily it was a right triangle, so you can't use that formula. So we're going to find the distance of AB and then BC, multiply them together. The area, of course, of a rectangle is base times height. So what is the length of AB? We use the distance formula again. As you can see, I plugged in the numbers for A and B, and I get radical 40, which, of course, as you know, we should simplify. It's actually 2 radical 10, right? And then we'll find the length of BC. Again, distance formula, I'm getting radical 10. So what's the area going to be? Well, the area is base times the height. So I got the 2 radical 10 for the base. I got the height is radical 10. 2 radical 10 times radical 10. Now, remember, when you're multiplying radicals, it's okay to multiply radicals. Just remember the numbers that are inside the radical will be multiplied by the other number that's inside the radical. So 10 times 10 is 100. And the square root of 100 is 10, and it gets multiplied by the 2. The final answer for the area of the rectangle is 20 square units. And that's going to do it for this section. We'll see you in class.